Hello everyone, welcome to data structures. Today we're going to talk about graphs. So far we learned about trees, different type of trees such as binary search trees and also able trees. And we learned that trees contain vertices and edges. A graph also contains vertices and a set of edges. So assume that we have a node or a vertex A and another vertex or node B. So this is a set of our vertices and an edge that connects these two nodes to each other. So graph G with set of vertices and edges, and our vertices will be A and B, and our edges will be A and B. So that's a very simple graph. Now let's talk about different types of graphs. Here we have a graph called G that contains 4 vertices, A, B, C, and D, and there are some edges that are connecting these vertices to each other. We call this graph an undirected graph, and because as you see there is an edge from A to B and also the same edge connects B to A. But we might have some graphs that there's an edge that goes from A to B, but there might be no edge that goes from B to A. So we call these kind of graphs a directed graph. So if we would like to connect B to A directly, we might draw another edge that connects B to A. So we call these graphs directed. Besides these two types of graphs, we also might have another type of graphs that are weighted. Okay, so here the graph that we see is unweighted. It means that the cost associated with the A to C is similar to the cost associated from A to B, also from B to A, or C to B, or B to D, or D to B. But let's say that the cost of traveling from A to B or going from A to B is 5, but the cost of going from B to A is equal to 10. So we call this graph a weighted graph. And let's say that the cost from A to C is also associated with 6 or is equal to 6. So we call this is a weighted graph. Now let's define some concept regarding graphs. So the first thing that we are going to learn is a path. So assume that we are going to go from vertex A to vertex D, or traveling from node A to node D. So we call this a path. So a path is a sequence of edges that goes from A to D. So we can say that a path from A to D, okay, is the edge AB, okay, here because also it's directed, and from B to D. So this called a path. Okay, so from A to B and then from B to D. Also we have another concept called a circuit, and a circuit is a path in which that the first node or the start node is equal to the end node. So here let's say that we are going to go from A to B and from B to C, and again from C we're going to go back to A. So then it's going to be there's going to be a circuit. The first node and the last node both are same, both are equal to A, so there's a circuit. And also, as you see, there is no edges that are repeated. So if we have a path in which the first node and the last node are same and there is no edges repeated, then we call this a circuit. So a circuit that goes from A to A might be A to B, then from B to C, then from C to A. So that's a circuit. Also, we might have a cycle. So a cycle is a circuit. So it means that it has all the features that a circuit has. But with this exception that exception of the first and the last vertices, means that here in this example the vertex is vertex A, all other vertices must be also different. So here we have the path that goes from A to B, B to C, and C to A is also a cycle. So this is also a cycle that goes from A to B, B to C, and C to A. So these are some concepts regarding a graph. Now let's look at this graph G that contains 4 nodes or 4 vertices A, B, and C and D. We call this graph a complete graph. A complete graph is a graph that there is an edge between every pair of vertices. So as you see, there's an edge from A to every other node that we see. So from A to B, from A to D, and also from A to C. Also from B to every other node, from C, and from D to every other node. So every node is connected exactly to n minus 1 other vertices. In n is the number of vertices that we have in the graph. So in this graph, the size of the vertices equal to 4. That means how many node or vertices we have. And the number of edges is equal to 6. And you may ask that how we get that number 6. So a simple answer to this question is, so there are n vertices. So in this case, n is equal to 4. Let's pick node A as the one node, and so we're going to say that from node A to any other node there's an edge. So it's going to be n minus 1 node or n minus 1 edges. But we picked A for n minus that are n minus edges for A. But also there are n minus edges for B and n minus 1 for D and C. So together we are multiplying this number of edges by number of vertices. But in an undirected graph, okay, the edge from A to B is same as the edge from B to A. So what we're gonna do is then dividing the number of edges by 2. So this is gonna give us the number of edges that in this case equal to 4 minus 1 multiplied by 3 divided by 2. That is exactly equal to 6 that we are seeing here. Now let's talk about subgraphs. So assume that we have graph G and another graph G prime. So as you see, graph G prime has nodes A, V, and C that also exist in graph G. Also, graph G prime has the edge from A to B and also from A to C or vice versa. So that exists in graph G. So we call graph G prime a subgraph of graph G because every vertices and every edge in G prime also exists in graph G. So if we have the graph G with a set of vertices and edges, and here we have G prime with V prime and V prime, so G prime is a subset of G because we have V prime that is a subset of V. Also we have E prime that is also a subset of E. Also, let's talk about trees again. So here the graph G prime is also a tree. So a graph G that doesn't have a cycle or a circuit called a tree. So all trees that we learned so far, like the Abel trees, binary search trees, binary trees, all of them also are graphs. So a graph without no circuit or no cycle, it's called a tree.